Hey everybody, we're going to do a little bit of sum and difference identities. So on that pink sheet that you have for your formulas, we're going to do a little bit more with some different ways that you can put angles together. So we're going to look at that next chunk on there, all the sum and difference identities, things that are always true. So we're going to start off with sum and difference for cosine. They have them written on your note sheet here, but I'm going to write them separately just so you can see them. They combine them so it's a little bit less writing. So the cosine of two different angles, if you're going to add them together, so alpha plus beta, is equal to, you can break it down into the components of just the individual angle measurements, so alpha and beta separately. So it's cosine of the first angle, alpha, times cosine of the second angle, beta, minus sine of the first angle, alpha, times sine of the second angle, beta. And the second version of it, they kind of combine them again in that top one. If it's a difference between them, so I'll just go ahead and write it as the difference, the only change in the formula is that it's a sum in between those two terms. So we're still using those four components, sine and cosine of both of the angles separately. You can figure out what the sine or cosine value is of the sum or difference of those angles. So we're going to be doing basically three different types of things with this. Verifying again like we did before, but then also some numerical things where we can actually look at triangles and work with that. But let's take a look at a verify now. That means just check, show that it's true. I'm going to expand this cosine using the sum formula because it's addition, so I'm going to have a sum of two things. So it's cosine of the first angle, so think of A like your alpha in the formula above, times cosine of the second angle, which is 180 degrees. Think of that like your beta in the formula above. Because it's a sum, that means in the formula I'm going to use a minus, and it would be sine of the first angle, which is A, that's your alpha, and sine of the second angle, which is 180 degrees. And what we're trying to show is that in fact equal to opposite of cosine? So for these verify, they're a little bit easier maybe than some of the ones we were doing because we have some numerical things we can actually do. I know those, or I should know those. Those are your unit circle, so they're coming back. So what is cosine of 180? It'd be negative 1. So negative 1 times cosine of A. Just going to put that coefficient out front. And then sine of A times sine of 180, which is 0. Only thing times 0 is just going to be 0. So that term is gone. And you're left then with negative cosine of A equals negative cosine of A. You've verified it. So just being able to check. So what that means is if you graph negative cosine of A, so think about what that graph would look like, reflected, it's going to be the same thing as shifting cosine 180 degrees to the left. So you would get that same graph. That's what that verify means. All right, well, we can do the same deal for sine. I'll write these two separately again. They have the sine of sum of two angles formula, and they combine it in your textbook, but I'll go ahead and write it separately first. So sum would be sine of the first angle, cosine of the second, plus cosine of the first angle, sine of the second. And again, they just split it up. I'm going to split it up just to make it easier for you to see. Difference, so alpha minus beta, and these are all on your pink sheet, and I wrote them separately there too, I think. Sine of alpha, cosine of beta. The only difference here is it's a difference. Get it? The difference is a difference. Awesome. Cosine of alpha, sine of beta. You're all groaning right now. It's okay. All right, so just want to bring my wonderful personality to you at home. So now, verify. We want to make sure that we can show, again, that these two graphs would be equivalent. So I'm going to use the difference formula, because it's a difference, and write out using the sine formula, thinking of my pi over 2 is your alpha, your x is like your beta. So the sine of my first angle, so I'm using the second formula right here, sine of the first angle, pi over 2, times cosine of the second, which is just x, minus, because it's subtraction in both, cosine of the first angle, pi over 2, times sine of the second angle, which is, oops, the x. All right, we're trying to prove or verify that that's the same graph as cosine. So let's do the numerical parts again. I know the answer to this, or I should, and this one as well. Sine of pi over 2, that's 90, so sine of 90 is 1. So 1 times cosine minus cosine of 90 is 0, so that second term is going to be 0. So I just get cosine equals cosine. So the verify part works pretty well, so it's not so bad. All right, now let's take a peek at what happens for tangent. To find the tangent formula, we're actually going to derive this one. I'm going to derive it from what tangent is equal to. Tangent is equal to sine over cosine, so it's sine of alpha plus beta over cosine of alpha plus beta. So if I think of the same sort of substitutions we were doing before, now I'm actually going to write out what those formulas are. So from the previous sheet, I'm going to write out the formula for what is sine of alpha plus beta. So that's sine of the first angle, cosine of the second, plus cosine of the first angle, sine of the second angle. I'm going to do the same thing on the bottom for cosine of alpha plus beta. That's cosine of the first, cosine of the second, minus sine of the first, sine of the second. So alpha and beta being the first and second. All right, now this is kind of a mess. It has a lot to it. What I'm going to do is make this a little bit easier, and I'm going to go ahead and divide every single term in this entire expression by cosine alpha, cosine beta. What I'm hoping to do is make tangents out of these. So if it's a tangent formula, it'd be nice if I use tangent in the equation for it. So to get a ratio that has tangent, I need cosines on the bottom. So I'm just going to take every expression in that fraction and divide it by cosine of alpha, cosine of beta. I'm going to do it for all four of them. And it's okay to do because I'm doing the same operation for every one. So I'm not changing the value, I'm just changing what it's going to look like. So I'm going to divide all four of them by cosine alpha, cosine beta, and then reduce and see what I get. That will generate my formula. So for the first one, the cosine betas cancel. So you're left with sine alpha over cosine alpha. Well, that's just tangent of alpha. Plus, in the next one, the cosine alphas cancel. You're left with sine beta over cosine beta. Well, that's just tangent of beta. And then over, everything cancels there, which leaves a factor of 1 minus. Nothing cancels, but look at these two products. Sine alpha over cosine alpha, that's tangent of alpha, and then times tangent of beta. So that's our formula for the sum of two angles for tangent. Now if we change it to a difference, the only change then is the sign. So if you look on the next slide there, we have the two tangent formulas. So they're generated, they're derived from the sine and cosine ones. We have the plus one that I wrote already. I'll write the subtracting one here separately. So if you have subtraction, the only difference again are the signs. So it's a subtraction on the top and then a plus on the bottom. All right, so for verify, for this one, we want to be able to show that these two are equal, the same as the other one. So I'm going to go ahead and write out that tangent formula, the pi being the alpha, the x being the beta. So tangent of pi plus tangent of x, so I'm using the sum formula, over 1 minus tangent of pi times tangent of x. And we're trying to prove that that's tangent. So again, a little bit easier than some of our other verify ones because I can do a couple of these. I have numbers for those. All right, so let's see what we get for that. So what is tangent of pi? Well, that's 180. Tangent is 0. So we have 0 plus tangent of x over 1 minus 0 times tangent of x. And I think we're in good shape then because look what happens on the other side here. Numerator's tangent over 1 minus 0 times tangent is 0, so over 1, which should just be tangent. So it works really well. It's the same as the sine and cosine. Well, it doesn't always work super awesome, though. Let's take a look at the next one. If you try to verify this and write it out, I'm just going to start this. You don't have to write this down. Tangent of 90 plus tangent of x over 1 minus tangent of 90 times tangent of x. Don't have to write that, just think about that for a second. If you're going to verify this and you have to substitute for those, what is the tangent of 90? It's vertical, that would be undefined. So I can't substitute in undefined. So I'm not going to be able to use tangent the way it's written. So how could we verify this? If you graph it on your calculator, they're the same graph. Well, go back to the definition. Tangent is sine over cosine. So if you go back to the definition for this one and actually write it as sine over cosine, those are continuous functions. We should be able to prove that's equal to negative cotangent of x. So if tangent is undefined, sometimes we have to kind of approach this a little bit differently. So think of this as your alpha and beta. We'll just write it out. So sine of 90 cosine of x plus cosine of 90 sine of x. We're just using our pink sheet there, our sum formula for sine. And then same on the bottom for cosine. Cosine of 90 cosine of x minus sine of 90 sine of x. And I bet a whole bunch of stuff is going to cancel, and we should be able to verify that identity. All right, so sine of 90 is 1 times cosine. Cosine of 90 is 0. And on the bottom, cosine of 90 again is 0. And sine of 90 again is 1. So let's see what we have left then. So this term is gone, that term is a 0. We're left with, on this left-hand side, cosine on the top, negative sine on the bottom, and I do believe that that would be negative cotangent, because cosine over sine is cotangent, and it's negative. So we verified the identity. So just kind of a heads up, if you're worried about that identity being verified, we have to use sine over cosine if tangent is undefined. Okay, so we spent a lot of time on verifying. I'm just going to introduce this. We're going to do a couple. We'll do more kind of on our day 2, but what we use these sum and difference formulas for are finding angles that we wouldn't normally be able to do, that are not necessarily a special angle by themselves. So we're going to take a look at a couple where we can try to break these apart a little bit. All right, so let's start with this. 435, first of all, is a big angle. I'm not even sure where it is, if it's a special value or not. So I'm going to find something that's coterminal with it to see if I can make an easier thing, because we know that the sine, cosine, and tangent values of anything that's coterminal have the same answer. So if I can use a coterminal that's easier, go for it. So coterminal is 75. Well, 75 isn't a special value angle, but if I can write 75 as a sum or a difference of two angles that are special values, I'm going to be able to use the unit circle to help me solve. So how about thinking about 75 as, think about your unit circle, what two angles that are on there could add or subtract to 75? How about 30 plus 45? That adds to 75, and I know values for both of those. So think of the 30 like your alpha and the 45 like your beta, and we can use that formula. So it's our sine sum formula. So look that up on your pink sheet or on your notes. It's cosine, or sorry, pardon me, sine of the first angle, 30 degrees, times cosine of the second angle, 45, plus, because it's a sum, cosine of the first angle, 30 degrees, times sine of the second angle, 45. So you're always using all four pieces, sine and cosine from both of those angles. Well, those are all things we know. We have exact answers for those. Sine is a half at 30. Cosine is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And sine of 45 is square root of 2 over 2. So now it's just a matter of doing some arithmetic. These numbers don't look fabulous, but it's an exact answer. We don't have to try to round or just do something on my calculator. So multiply the fractions together. Remember, when you multiply radicals together, you multiply the numbers underneath. So we get this expression square root of 2 plus square root of 6 all over 4. If you do the decimal equivalent for that, try typing that into your calculator. Do the decimal for that over there and try typing in sine of 75. Make sure you're in degree mode. You should get the exact same decimal for both. It's a way to write it as an exact answer. Kind of handy. So we're able to solve for things that we wouldn't normally do. Okay, we'll wrap it up with one tangent formula. Do the same thing. Tangent just presents us a little bit more arithmetic, but we can do the same idea. 255, definitely not a special value angle, but if we can write it as a sum or difference of two angles that are, then we can use our sum and difference formulas. So let's see if we can come up with a pair that adds or subtracts to 255. I was thinking 45 plus, find on your unit circle, how about 210? Those are both special values. So I can write out my formula. It's a sum formula. Tangent of the first plus tangent of the second over 1 minus tangent of the first times tangent of the second. And then we can go ahead and put our values in. So just be careful. Try to think ahead a little bit here about what might work. Tangent of 45 is 1. Tangent of 210, that's a 30-degree reference angle. And tangent of 30 degrees is square root of 3 over 3. Because it's in quadrant 3, it would be a positive answer, right? So that would be a positive number there in quadrant 3. So plus square root of 3 over 3 And then in the denominator, we have 1 minus, tangent of 45 is 1, and then times square root of 3 over 3 again. All right, so from here on out, basically we have just a whole lot of arithmetic to do. We need to get common denominators, we need to multiply by the reciprocal just to make this look a little bit better. So think of your 1, it's like 1 over 1, so we can get a common denominator there. So think of it as 3 over 3. So we'd have 3 plus square root of 3 all over 3. In our denominator, we're going to do the same thing. Think of this 1 as 1 over 1, which would be 3 over 3. So 3 minus square root of 3 over 3. All right, this is all algebra stuff. So then I'm going to multiply by the reciprocal. So we're going to get a few things to cancel out here, just one thing anyway. So I can get those 3's to cancel. So I have 3 plus root 3 over 3 minus root 3. Now the nice thing on an AP Calc test, you could probably leave it like that. Your book is assuming you know how to rationalize something to make it not have a radical in the bottom. So that's where we need to multiply by the conjugate. We're going to multiply top and bottom by 3 plus square root of 3. So top and bottom will multiply by that. And then just a little bit more arithmetic, and we're good to go. So in the numerator, let's FOIL. So it'd be 9 plus 3 root 3 plus another 3 root 3, and then square root of 3 times square root of 3 is 3. On the bottom, we'd have 9 minus square root of 3 times square root of 3 would be 3. So it looks like 12 plus 6 root 3 over 6. And one last thing we can do, we have a common factor of 6. So we have 2 plus root 3, so dividing each of those. So if you take tangent of 255 on your calculator, you get a positive answer there. We're going to get that same 2 plus root 3 as our positive answer for the other one. So as we go through and take a look at that, we do get a pretty decent answer as far as that goes. So this is just the introduction to sum and difference. We're going to do some more tomorrow as well, just to get us started here though on verifying and a little bit of rewriting. So tomorrow we'll work more on that.